The first question says that ABC is a right angle triangle. Work out the length of CB. Give your answer correct to 3 significant figures. So easy question. You just need to apply Pythagoras over here because we have 2 lengths and the third length is an unknown. So the hypotenuse square, which is 19 square, equals to 10 square plus CB square. 19 square minus 10 square equals to CB square, which is 261. Now we will square root both sides. And that gives us 16.2 centimeters, correct to 3 significant figures as the length of CB. Next question says, write 90 as a product of its prime factors. So we draw the tree diagram, split 90 into 2 factors. I'm going to pick 30 and 3. 3 is a prime number, so it stays as it is. Then you split 30 as 5 and 6. 5 is a prime factor, so it remains as it is. 6 splits into 3 and 2. So as you can see, all the numbers are prime numbers, so we can't further break them down. So 90 is the same as 2 times 3 times 3 times 5, which can be rewritten as 2 times 3 square times 5. That is your answer. Then it says A equals to 2 square times 3, B equals to 2 times 3 square. Write on the lowest common multiple LCM of A and B. So when we talk about the LCM, 2 square times 3 is 12. And 2 times 3 square is 18. So the lowest common multiple of A and B is going to be 12 and 18 over here. So we know 12 and 18 are divisible by 3. So that's 4. And this is 6. 4 and 6 are divisible by 2. 2 and 3. 2 is only divisible by 2. And 3 is only divisible by 3. So 3 times 3 times 2 times 2. That's 9 times 4, and that is 36. So LCM is 36. An alternate method is that you can just pick the numbers which are greater in, like, occurring in both the numbers. So in A, we know 2 square is bigger for 2, and B, we know 3 square is bigger for 3. So 2 square times 3 square, 36. So that's your answer. Question 3 says the number of hours H that some machines take to make 5,000 bottles is given by H equals to 72 divided by N, where N is the number of machines. On Monday, 6 machines made 5,000 bottles. On Tuesday, 9 machines made 5,000 bottles. The machines took more time to make the bottles on Monday than on Tuesday. How much more time? So first, we're going to find the value of H, which is the number of hours. So for Monday, it's going to be 72 divided by 6, which is equal to 12. And for Tuesday, it is going to be 72 divided by 9, which gives us 8. So how much more time did it take on Monday? We do 12 minus 8, and that's 4. So 4 hours is your answer. Question 4 says there are only red discs, blue discs, and yellow discs in a bag. There are 24 yellow discs in a bag. Mel is going to take at random a disc from the bag. The probability that the disc will be yellow is 0.16. The number of red discs to blue is 5:4. Work out the number of red discs in the bag. So using the probability of yellow discs, what we're going to do is we're going to first find the total. So 0.16, which is the probability of yellow, equals to the number of yellow discs, which is 24, divided by the total. So total is going to be 24 divided by 0.16, which gives us 150. So now to find the remaining number of discs, which is the red and blue. So remaining discs, we're going to do 150 minus 24, which is 126. Now these 126 discs include the red and blue discs. So since you have to find the number of red discs, red will be 5/9 of 126. How did we get 5 nines? We added 5 and 4 in the ratio, so that becomes the denominator. And numerator of the fraction is your number of red discs in the ratio, which is 5. So 5 over 9 times 126, which is the number of red and blue discs, and that is equal to 70. So we have 70 red discs. Question 5 says complete the table of values for y equals to x squared minus x. So simple, you will just substitute the values of x in this equation to find the corresponding y values. So y equals to negative 1 square minus negative 1, which will give us 2. Then y equals to 1 square minus 1, which gives us 0. So 2 over here and 0 over here. And y equals to 3 square minus 3, which gives us 6. So this is our complete table with the values. Now we're going to plot these points in part B and see what our graph looks like. So let's write down the points on the side. 2, 2, and 3, 6. So if you plot this now, negative 2, 6 is over here. Negative 1, 2 is over here. 0, 0, 1, 0, 2, 2, and 3, 6. That's your graph. I remove this point. That's a quadratic graph. Then it's saying use your graph to find the estimates for the solution of the equation x squared minus x equals to 4. So if you remember, the original equation was y equals to x squared minus x. So now they've replaced y with 4. So that means we're going to draw a line at y equals to 4, and wherever it intersects the graph, those are going to be our solutions. So approximately what I'm getting over here is negative 1.5 and 2.7 over here. These are my estimate solutions when the equation equals to 4. Question 6 says Andy, Luke, and Tina share some sweets in the ratio of 1:6:14. Tina gives 3/7 of her sweets to Andy. Tina then gives 12.5% of the rest of her sweets to Luke. Tina says now all three of us have the same number of sweets. Is Tina correct? You must show how you got your. I must show how you get your answer. So to show if Tina is correct, what we're going to do is first we're going to create fractions from this ratio for all three. We know Andy is 1/21. We know Luke is 6/21. And Tina is 14/21. Now Tina is giving 3/7 of her sweets to Andy. So if she's giving 3/7 of her sweets to Andy, we multiply 14/21 times 3/7, which gives us 6/21, which simplifies to 2/7. Now remaining sweets for Tina is going to be 14/21 minus 2/7, which is equal to 8/21. This is what Andy got from Tina. Okay. So now from these remaining 12.5% were given to Luke. So before we do that, I'm going to write what Andy has now. Andy has 1 over 21 plus 2 over 7 now, which is 7 over 21. This is what Andy has. So I'm going to highlight this over here. This is what Andy has right now. Now going back to Luke. So for Luke, we're going to first find 12.5% of 8 over 21. So 8 over 21 times 12.5 over 100, which equals to 7 over 1 over 21. So now Luke will have 6 over 21 plus 1 over 21, which is 7 over 21. So let's highlight this as well now. This is what Luke has. This is what Andy has. Now to find what Tina is left with, again, remaining, or more like Tina final sweets. Tina final sweets. For Tina, our final sweets are going to be 8 over 21 minus what she gave to Luke, which is 1 over 21. That is 7 over 21. As you can see, all three have the exact same fraction for sweets. Tina 7 over 21, Andy 7 over 21, and Luke also 7 over 21. Let me just highlight this over here. This is what Luke got from Tina. So if we compare them, it's exactly the same. They have the same ratio. 7 over 21 is to 7 over 21 is to 7 over 21, which simplifies to 1 is to 1 is to 1. So yes, she is correct. Question 7 says ABCD is a quadrilateral. All angles are measured in degrees. Show that ABCD is a trapezium. So to show that a quadrilateral is a trapezium, what we need to do is that we need to remember that angles lying on one line, and by that line, I mean this line, these two are supplementary. Similarly, these two are also supplementary. So what we're going to do is that I'm going to pick this angle and use this to find the value of x and to prove that this is a trapezium. So since these two are supplementary, that means the sum of these two angles would equal to 180. So 4x plus 15 plus 2x plus 15 equals to 180. So that is 6x plus 30 equals to 180. 6x equals to 180 minus 30, 150. And x is 150 divided by 6, which is 25 degrees. Now if we find the first angle, 4 times 25 plus 15, that equals to 115. Then the other one, 2 times 25 plus 15 equals to 65 degrees. So when you add 115 and 65, that equals to 180. Hence, supplementary angles. So this is how you know that this is a trapezium. Question 8 says the playground is in the shape of a right angle triangle. Dan makes a scale drawing of the playground. He uses a scale of 1 centimeter, which represents 5 meters. The area of the playground on scale drawing is 28 centimeters square. The real length of QR is 40 meters. Work out the real length of PQ. So this is what we have to find. So first, let's convert the scale drawing area to the real area. So if 1 centimeter represents 5 meters, 1 centimeter square will represent 25 meters square. So real area would be 28 times 25, which will give us the value of 700 meters square. After that, we're going to put 700 equal to 1 over 2 times 40 times PQ, because this is a right angle triangle. And area of a triangle is 1 over 2 times base into height. Base is PQ, height is 40. So 700 times 2, which is 1400 divided by 40. That's going to give us 35 meters. 35 meters. So that is your real length of PQ. Question 9 says the number n is rounded to two significant figures. The result is 7.3. Write on the least possible value of n. So least possible value of n is going to be 7.25. Then it says, Leila says the value of n cannot be greater than 7.349 because 7.350 would round up to 7.4. Is Leila correct? Leila is not correct because we can also round 7.349 can also round to 7.3, correct, to 1 decimal place. The value cannot be greater than 7.3, not 7.349. Question 10 says diagram shows two right angle triangles. All lengths are measured in centimeters. Given that sine A equals to tan B, work out the value of x. Sine is basically opposite over hypotenuse. Opposite is the length opposite to the angle that is the reference angle, and hypotenuse is the diagonal. So sine A is going to be 7 minus 2x divided by 8. And tan B is going to be 1 plus x over 4. Because tan is opposite over adjacent. Adjacent is the length on which your angle lies. So both are equal to each other. Cross multiply. So 7 minus 2x equals to 8 times 1 plus x over 4. 4 ones are 4, 4 twos are 8. So now we have 7 minus 2x equals to 2 plus 2x. Let's just move them to here. 7 minus 2x equals to 2 plus 2x, because we expand the bracket, bring the variable on one side and the constants on the other. So 7 minus 2 equals to 2x plus 2x. That's 5 equals to 4x. And 5 over 4 is your x value. Question 11 says the frequency table gives information about the weights of 60 parcels, and we have to complete the cumulative frequency table. So when we're trying to find the cumulative frequency for frequency, what we do is we add the frequency values, the consecutive frequency values to each other. So we start from the first value. 7 will be 7, but next would be 7 plus 21, which is 28. Then the next would be 28 plus 15, which is going to be 43. Then the next would be 43 plus 11, which is 54. And last one would be 54 plus 6, and that's 60. That's your answer. On the grid opposite, draw a cumulative frequency graph for a table. It's going to be 2, 7, 4, 28, 6, 43, 8, 54, and 10, 60. Remember, whenever you're drawing the cumulative frequency for your x coordinate, you will take the maximum values of the class intervals. And the y coordinate is going to be your cumulative frequency. So 2, 7 is over here. 428 is here. 643 over here. 854 is here. And 1060 is here. Just select the dots. Make a cumulative frequency graph. Then it's asking us to estimate the interquartile range. So for the interquartile range, we need the lower quartile and the upper quartile. Lower quartile is 1/4 of your total frequency. So 60 times 1/4, that's going to give us 15. So what you will do is you will draw a line from 15 and find your corresponding weight. That's 2.9. And then we do the same for the upper quartile. That's going to be 3/4 of 60, which is 45. That is 6.2. The interquartile range, we subtract the upper quartile and lower quartile, and that gives us 3.3. That is my interquartile range. Then it says use a graph to find an estimate for the number of these parcels with a weight greater than 7.4 kg. So for a weight greater than 7.4 kg, wait first. Okay. Greater than 7.4 kg, so that's going to be this. So since it's greater than 7.4 kg, we're looking at these values. So we'll do 60 minus 52, which is 8. So that's my answer. Question 12 says f is inversely proportional to d square. F equals to 3.5 when d equals to 8. Find an equation for f in terms of d. So if f is inversely proportional to d square, then f equals to k over d square. Because when f is increasing, d square is decreasing and vice versa. So 3.5 equals to k. K is your constant of proportionality divided by 8 square. So 3.5 times 64 is k. And that is going to give us 224. So your equation is f equals to 224 over d square. Then it says find the positive value of d when f equals to 10. So using the same equation, 10 equals to 224 over d square. D square equals to 224 divided by 10. So d square equals to 22.4. We square root both sides. And what we get is plus minus 4.73. But since they want the positive values, it's going to be positive 4.73, not the negative one. Question 13 says on the grid, shade the region R that satisfies the following inequalities. So first one is x is less than equal to 2. So we draw a line at x equals to 2. And the shaded part is going to be this is going to be our shaded part. Then it says y is greater than equal to -3. So draw a line at -3. Just going to label this as well. X equals to 2. Y equals to -3. So for y equals to -3, it's greater than equal to. So that means above the line. So now y is less than equal to 2x plus 1. So the y-intercept is 1. So the y-intercept is 1 and your gradient is 2. So rise over run. So when x is 0, y will be 1. When y is 0, x will be -1 over 2. So if we connect this, that's our third line. Y equals to 2x plus 1. And for this, the shading is less than. So that means it's going to be under. And for the last one, 3x plus 2y is less than equal to 6. So if you put x equals to 0, we get y equals to 6 when x is 0. And when y is 0, x is 2. So this is 1 point. This is the y is 3, not 6. This is the other point. So if we connect the points, and is less than equal to, so it's going to be over here. So as you can see, this is the overlapping region, the one in the middle. So if I remove everything else, this is our region that we're concerned about. This is R. Question 14 says diagram shows the velocity of a car in meters per second, t seconds after it starts to slow down. Calculate an estimate for the acceleration of the car when t equals to 5. You must show all your working. So velocity time graph, the gradient of that would be acceleration. So that's why what we'll do is we'll draw a line at t equals to 5. Then we'll draw a tangent over here and define the value for the gradient of the graph at t equals to 5, which is basically the acceleration at t equals to 5. We find the gradient of the tangent because the gradient of the tangent of the graph are going to be the same at that point. So I'm going to pick 2 points, preferably whole numbers. I'm going to pick this point, and I'm going to pick this point. So this is 5 and 4 point. That's going to be 7.5. 10 divisions. So 5 divided by 10, that's 1 over 2, 0.5. So each small division is 0.5. 5.5 plus to 5.75. No. We have 10 divisions from 0 to 5. So 10 divided by 5, 2. Each small box represents 2 units. So 1, 2, 3, 4, 5. This is 6, so in the middle, 5.5. 5.75. And this point is 1, 2, 3, 4, 5. That's 7, 2, 4, 7.4. And y is 1.75. 0.75 actually. Yeah. Okay, so for the gradient, 5.75 minus 0.75 divided by 5 minus 7.4, and that is going to give us negative 0.68. That is our acceleration at t equals to 5. Then it says work out an estimate for the distance the car travels in the first 6 seconds after it starts to slow down. Use 3 steps of equal width. 1, 2, 3. So we're going to assume that this is a trapezium, like these divisions. And the formula we're going to use is 1 over 2 times a plus b times height. These parallel lengths are your a and b, and these are your heights, height 1, height 2, height 3. So for the first one, it's going to be 1 over 2. Let me name this area 1. This is area 1. This is area 2. This is area 3. So that's 1 over 2 times 25 plus 16 times 2. So that is 41. Area 2 is 1 over 2 times 16 and 19. 16 plus 19 times 2. So that's going to be 35. And area 3 is going to be 1 over 2 times 0.534. 4 plus 19 times 2 again. And that is 23. So distance is going to be the sum of 41, 35, and 23. And that's going to give us 99 meters. That's the distance that I'm getting for this graph here. Question 15 says, given that a is a prime number, rationalize the denominator of 1 over root a plus 1. Give your answer in its simplest form. So in rationalizing, we multiply and divide the fraction by the conjugate, which is the same thing in the denominator, but with the opposite sign in the middle. So root a minus 1 is what we multiply it with. So root a minus 1 divided by root a plus 1 times root a minus 1. Now the denominator must remind you of difference of perfect squares, because in difference of perfect squares, what we're doing is that a square minus b square equals to a plus b times a minus b. The same thing is added in one bracket and subtracted in the other. So that's going to be root a minus 1 over root a being squared minus 1 squared, which is once again root a minus 1 over a minus 1. And this is the simplest form. We can't further simplify. Question 16 says solve 4x minus 3 times x plus 5 less than 0. So inequalities. So they've already simplified the answer for us. All we need to do is make a graph and see what the solution is going to be. So x equals to -5 and x equals to 3 by 4. This is a quadratic curve. Let's write that over here. 3 by 4. And since it's less than 0, that means we look at the values of y underneath the x-axis because they're decreasing. So this is where the y values are decreasing. So if you look at the behavior at x equals to -5, at x equals to -5, your values of x are increasing because they're going towards the positive side. And at x equals to 3 by 4, your values of x are decreasing because they're going towards the negative side. Now, the thing is, since the two values are converging, so that means we need to write the answer as a joint inequality. If the two values were diverging, then you would write them separately. So the final answer would be x is less than 3 by 4, but it's greater than -5. That's your answer. Question 17 says L, M, and P are similar solid cylinders made from the same material. L has a mass of 64 grams, M has a mass of 125 grams. M has total surface area of 144 centimeters square. P has total surface area of 16 centimeters square. Work out the height of cylinder L is to height of cylinder M is to height of cylinder P. So what we will do in this case is that you need to remember that when an object is made from the same material, that means density is same. Now, density has the formula of mass over volume. So if we pick solid L first, density is 64 divided by volume of L. For M, density is 125 divided by volume of M. Like I said, the same material, same density. So we can put these fractions equal to each other. 64 over VL equals to 125 over VM. Swap the places. 64 over 125 equals to VL over VM. Now, if you remember, in similar shapes or like solids, whether it's like 2D or 3D, your ratio of the volume is equal to the ratio of the cube of the lengths given for the shape. So basically what I mean is that this equals to this. So that means this is 64 over 125 can be put equal to this, and we can find the height of shape L and M. So 64 over 125 equals to HL over HM cubed. Take the cube root, and that gives us 4 over 5 for HL and HM. So we have a ratio for HL and HM. Now, we need to figure out the ratio for P. So for M and P, they have given us the surface area. So what we're going to do is that using this same concept for your similar shapes, we know that area of M over area of P is the same as HM over HP being squared now. In case of volume, we cube it. In case of area, we square the ratio. So area M 144 over 16 equals to HM over HP squared, square root both sides, and we have 12 over 4 for HM is to HP. Now we can see that we have common HM in both the ratios. So what we will do is that we're going to write them separately and then combine them. So HM is to H. So HL is to HM is 4 is to 5. HM is to HP is 12 is to 4. As you must remember, when you're trying to combine two ratios into one single ratio, you need to make sure that the common quantity in both the ratios is the same. In our case, that's the height of M. Now, M is 5 in the first ratio and 12 in the second ratio. So to make it the same, we need to multiply this by 12 and this by 5. Now, since this is being multiplied by 12, we have to multiply this by 12 as well and this by 5 as well. Because you can't just change one quantity, you have to change both of them. So that's going to be 48 is to 60 is to 20. We can combine it as a single ratio now because we have the same quantity for HM now. Now, if you simplify this, they're all divisible by 4. This is going to be 12. This is going to be 15. And this is going to be 5. This is your answer. Question 18 says there are only 4 red counters, 3 yellow counters, and 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow counters than red counters in the bag. You must show all your working. So right now we have 4 red counters, yellow 3, and green 1. We have to work out the probability that there are now more yellow counters than red counters in the bag. So that means he's taking red counters out. So Tony will be taking more red counters out of the bag. So let's in the first try, he's taking all 3 red counters out of the bag. So when he takes all 3 red counters out of the bag, which is 3 red counters, so red counters are 1, yellow counters are 3, and green are 1. So as you can see, there are more yellow counters left in the bag if he takes 3 red counters. So that's 4 over 8 plus times 3 over 7 times 2 over 6. This is the probability for all red counters. Now, the reason why it's 4 over 8 times 3 over 7 times 2 over 6 is because he's not replacing the counters. He took 3 counters, so there are 3 less counters in the bag. So when he took the first red counter, the total number of counters reduced to 7 and the number of red counters reduced to 3. Then when he took another red counter, again, like 1 reduction. So that's why it's 4 over 8 for the first red counter, 3 over 7 for the second red counter, and 2 over 6 for the third red counter. That gives us the probability of 1 over 14. Now, the second condition is that he takes 2 red counters and 1 green counter. The reason why I did not take 1 yellow counter is because if we took 1 yellow counter and 2 red counters, that would leave us with 2 red and 2 yellow. We don't want that. We want the yellow number to be greater. Hence, we take 2 red and 2 green. Hence, we took 2 red and 1 green. So that's going to be 4 over 8 times 3 over 7 times 1 over 6. So that is going to give us 1 over 28. Now, we don't have a third condition because if we took 1 red, 1 green, and 1 yellow, the number of yellow and red counters would be the same. So either we can take all red counters, like all 3 red counters, or we take 2 red and 1 green. We cannot take a yellow counter in any case because yellow counters are already less than the red counters. So they're asking us to work out the probability that there are now more yellow counters than red counters. So for that, we added 1 over 14 and 1 over 28. And that gives us 3 over 28. That is your answer. Question 19 says diagram shows a quadrilateral OACB M is the midpoint of OA, N is the midpoint on BC such that BN is to NC is 4:5. OA is given as A, OB is given as B, and OC is given as K times B, where K is a positive integer. We have to express Mn in terms of K, A, and B, giving your answer in its simplest form. So Mn is this. And what we can do is that to find Mn, we know M is the midpoint of OA. So that means this is A over 2. OB is given as B. And AC is given as K times B. So first, I'm going to find BC. So BC is going to be BO plus OA plus AC. That's negative B, because OB is given as B, so BO would be the opposite, so negative sign. Plus A, because OA is A, and AC is K times B. So this is our BC. So we know N is on BC with the ratio BN is to NC is 4:5. So to find BN is going to be 4/9 of BC. This is what we're trying to find. So that's going to be 4/9 times negative B plus A plus K times B. So to find Mn, I'm going to do MO plus OB plus BN. These are the vectors I'm going to use to find Mn. So that's going to be Mn is MO plus OB plus BN. So that's negative A over 2 plus B plus 4/9 times negative B plus A plus KB. So when you solve that, we have a denominator of 18, and we have negative 9A plus 18B minus 8B plus 8A plus 8KB. So if you simplify that, that's going to be negative A plus 10B plus KB over 18. This is what I get for Mn. Then is Mn parallel to OB? So Mn was negative A plus 10B plus 8KB over 18. OB is B. Mn and OB cannot be parallel to each other because Mn has the vector A in it, whereas B doesn't. So no, they're not. Because Mn has vector A. Question 20 says the curve C has equation y equals to 2x squared minus 12x plus 7. Find the coordinates of the turning point on C. So to find the turning points on C, we need to do the completing square form. So first, we need to make the coefficient of x squared 1. So to do that, we're going to take 2 common from the entire equation. So it becomes y equals to 2 times x squared minus 6x plus 7 over 6. Next, what we do is, whatever the value of b is, which is 6 now, we have ax squared plus bx plus c. So b is the quotient of x, which is negative 6. Or I'm just going to take it as just 6. So we divide 6 by 2, which gives us 3. So we're going to add and subtract 3 to this equation. I'm going to add and subtract 3 square to this equation. So plus 3 square minus 3 square, then plus 7/6. Now the reason why we're adding and subtracting 3 square from this equation is because we're trying to complete the square. Right now, this is what we have, x squared minus 6x. 7 over x is not a part of the square because when we split it, like a minus b whole square, a minus b whole square is a square minus 2ab plus b square. So over here, a square is x square, 2ab is 6x. 6x equals to 2ab is 6x equals to 2xb, which is 3. So b is 3, not 7/6. So that's why we're adding and subtracting 3 squared. Now the subtraction part is because like we're introducing a new term and that new term is being added. So if a new term is being added, we have to subtract as well to maintain a balance. So keeping that in mind, this is what we have. Now we're going to combine the x square minus 6x plus 3 square as x minus 3 square. That is this complete square. And this 3 square will be outside. So that's minus 9 plus 7/6. Let me just erase that. So that's y equals to 2 times x minus 3 square minus, this is going to be 2, not 6. My bad. Because we're getting 2 common, not 6. This is 2 also, yeah. So that's negative 18 plus 7/2. Multiply the 2 with everything. So 2 times x minus 3 squared. And 2 times 1/2, the 2 gets cancelled out. So that's minus 11. So turning point is basically this is your h value and this is your k value. And h and k are your turning points. So your h value is 3 and k value is negative 11. That's the turning point of C. Question 21 says that the graph of y equals to g of x is shown on the grid. On the grid, draw the graph of y equals to g of negative x plus 2. So g of negative x plus 2. So g of negative x shows that there's a reflection in the y-axis, and the plus 2 shows that there is a vertical translation. So when we reflect the coordinates in the y-axis, this point, let me just label these first over here. So 3, 1 will become negative 3, 1, and negative 1, 1 will become positive 1, 1. And 1, 2 will become, 1, negative 2 will become negative 1, 2. So let's plot these first. Okay. So if I draw the graph for this, this is g of negative x, just that. Now, plus 2, so that means we move this graph 2 units up. So for 2 units up, negative 2 will come over here, 1 will come over here, and this one will come over here. So this is g of negative x plus 2. Question 22 says A and B are points on a circle center O. M, A, P, and N, B, P are tangents to the circle. Prove that A, P equals to B, P. So this has to equal to this. So first, we need to remember that OA and OB are equal because they represent the radius. So OA equals to OB because radius. Second thing is that the line OP is common between both these triangles. So OP is common. So this is another equal length. So we have two equal lengths so far. And the third thing is that a tangent makes a 90-degree angle with the radius. So angle PAO equals to angle PBO, which is 90 degrees. So we can clearly see that both the triangles are congruent because they have the same angle, they have the same two lengths, so third length is also going to be the same. And the property we're using is that side angle side. And by CPCT, your AP is equal to BP. That's how you prove that AP is equal to BP, because they're both right angle triangles and their radius that's congruent, the common length that's congruent, the angle is congruent. So yeah.